the 6 trigonometric functions. All right, so up to this point, we've talked about sine and cosine. Those are 2 trigonometric functions that we've talked about, and we define them using a point on the unit circle where an angle theta terminates. But there's 4 additional trigonometric functions, and these make up, between the 6 of them, all of trig, really. So let's start with what we had already. Cosine of theta, if we're using the terminal point on the unit circle, cosine is x. Sine of theta is y. Right? Again, even though this says cos, you don't say cos, you say the full name, cosine, sine, and for these remaining 4, their full names as well. All right, so tangent of theta, which we write as tan theta, all the trig functions, they'll have 3 letters. That is y divided by x. Cotangent of theta, which we write cot, cotangent of theta is x over y. Secant of theta, which we do sec, is 1 over x. And cosecant of theta, which is csc, is 1 over y. So defining trigonometry using the unit circle, this is one way we can define trigonometry. These definitions using this coordinate point. The next section will be going over a different way to define trigonometry and the trigonometric functions. But this is one way. You might say, where in the world did any of these things come from? Well, tangent of theta becomes really important in calculus. You may notice y over x kind of reminds you of, I don't know, slope, where it's the rise over run, right? Change in y over change in x. Tangent becomes really important there. And these guys down here, you'll notice that they are very similar to the ones up here. They'll play a very important role very soon. So let's do a few problems. Find the 6 trig functions for theta equals 5 pi over 3. So we are looking for cosine of 5 pi over 3, sine of 5 pi over 3, tangent of 5 pi over 3, secant of 5 pi over 3, cosecant of 5 pi over 3, and cotangent of 5 pi over 3. Here's what I want you to notice. Oop. All right, let's see. Did these a little tiny bit out of order. That's okay. Let's shrink these down just a tiny bit. Boom. Move them a little further away from each other. Probably could have done this off camera, but you're here for it, right? All right. I want you to notice some relationships here. Cosine and secant are the reciprocals of one another. A reciprocal is 1 over that number, right? 1 over x. So the reciprocal of x is 1 over x, and the reciprocal of 1 over x is 1 over x, which is x. So they're reciprocals of one another. And I like to think of them personally as soulmates. We have 3 pairs of soulmates here, and I find this really, really helps. Cosine and secant are soulmates. Sine and cosecant are similarly soulmates. They are reciprocals of one another. They're really just the fraction flipped upside down, because x is the same as x over 1. So if you flip it upside down, you have 1 over x. It's the same thing with y, right? Y is the same thing as y over 1. So its reciprocal is 1 over y. And tangent and cotangent, they are also the flip of one another. They're reciprocals of one another. And they're all soulmates. So tangent and cotangent are the easiest to remember because they have the same type of name. So tangent and cotangent are soulmates. They're reciprocals of one another. And then to remember these guys up here, I remember you match C's and S's together. So there's 2 C's, there's 2 S's, and they're not paired together. Cosine is paired with secant. Sine is paired with cosecant. That's how I remember it. And they're soulmates. So here's the easy part. We can do this real easy. We need to find the coordinate point x comma y for the angle 5 pi over 3. And let's see. Oop, there we are. 5 pi over 3. So I'm going back to that unit circle we did in an earlier video. And oop, there it is right there. Copy, paste. It's the point 1/2 negative root 3 over 2. So cosine is the x value, and the x value here is 1/2. So cosine of 5 pi over 3 is 1/2. Sine is the y value. So the y value is negative root 3 over 2. Sine of 5 pi over 3 is negative root 3 over 2. Tangent of 5 pi over 3, that's going to be y divided by x. So negative root 3 over 2 divided by 1/2. Ooh, I should have wrote y over x. That's what we're doing there. Easiest way to, boom, make that a little shorter. Easiest way to do this is to multiply the numerator and the denominator of the big fraction by 2. That will cancel out. Boom, 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 boom. You're just left with negative root 3 over 1, which is just negative root 3. So tangent of 5 pi over 3 is negative root 3. Let me highlight these answers here. All we have to do, as long as you're careful about how you write this, and notice that I put soulmates across from each other, and I always do this. Soulmates belong across from one another. So all I have to do to find secant is flip the fraction upside down. So it's going to be 2 over 1, which is just 2. Secant of 5 pi over 3 is 2. Cosecant, we're going to take this sine value over here and flip it upside down. So it's still negative, but now it's 2 over root 3 as opposed to root 3 over 2. I'm not going to rationalize it because I don't need to. You may have had a high school teacher at some point tell you that you have to rationalize your denominators, otherwise the number is incorrect. And that is not a correct statement. There's nothing improper about radicals in the denominator. The only thing that is awkward about them is it's harder to add and subtract fractions when you have radicals in the denominator. But there's nothing wrong with leaving it that way. And I would honestly prefer it because it shows the connection between these two values. All right, and then the reciprocal of negative root 3 over 1, I can just put the 1 there, right? If I put the 1 there, then it becomes negative 1 over root 3, which again, I'm just going to leave there, just like that. And those are the 6 trigonometric functions for 5 pi over 3. Not so bad, right? There's worse things. All right. Another problem. Suppose theta is an angle in standard position whose terminal side intersects the unit circle at the point 5 comma 6, or 5 over 6 comma negative root 11 over 6. Find all 6 trig values. So a quick picture of what's happening here. Here's the unit circle. We have a positive x value, so somewhere over here, right? And then a negative y value, so that means it has to be in this guy right here, quadrant 4. So I don't need to draw an exact picture of this. I can simply just say, I know it's in here. I know it's in here. I just want to draw a quick picture so that you have an idea of what's happening. This is the point 5 over 6 comma negative root 11 over 6. They're saying that this is true on the unit circle. So where negative 1 is here, positive 1 is here, positive 1, negative 1. We just want to find the trig values using this value. So literally, you just use this coordinate point. You just use this coordinate point. It has the x and the y value. You use these definitions and soulmate ships to find the answers. So let me go ahead and duplicate. We don't know what the angle is here. So the angle is theta for us. All right. Cosine is x. The x value is 5/6, directly from the coordinate point. X, y, x, y. If I wanted, I could immediately go and write secant of theta. I do need to put the theta there. You can't just write secant. Secant of theta. Don't know what theta is, but so we don't know what this angle is. This is what theta is. We don't know what it is, but we do know this point. Anyways, flip 5/6 upside down, you get 6/5. Sine of theta is y. So that's negative √11/6. Flip it upside down, you get cosecant of theta is equal to negative 6/√11. Oh, hold on. All right, there's a little bit of screaming there. These videos, well, you know you're not getting a professionally produced YouTube video here, right? This is the real experience. I'm recording this at home and my son is ready to brush his teeth. All right, sorry, back to where we were. Cotangent of theta. Was that not what we were writing? What were we writing? Oh, yes, over here. We had finished writing sine of theta, and that was y. We flipped it upside down. Now we have cosecant of theta. Finally, for tangent of theta, which is y divided by x, we have y is negative √11/6 divided by x is 5 divided by 6. All right. I'm multiplying the numerator and the denominator of the big fraction, so the fraction whose bar is right here, by 6. I'm going to get negative √11. These cancel, negative √11/5. Oop. And if I flip it upside down to get cotangent, I have 5 over negative √11. And those are my answers. All right. So really, what I need you to know, see, if you have these memorized, you don't need to memorize this. It's really just unnecessary. Memorize this, then memorize the soulmates. And then everything is just going to be perfect. It'll be super, super easy. I promise. It's not a waste of time to learn this. It'll help you. All right. That's it for this video. Thanks for sticking around, and I'll see you in the next video. Bye.